This is the Authority Partners podcast.
Hello, everybody. My name is Mirano Galiašević. I'm working for Authority Partners, head of R&D, and with me is Steve Smith, also known as Ardalis. He is a founder and principal architect at NimblePros. NimblePros helps teams build better software faster, and they are generally helping financial companies migrate to cloud-native architecture. So, Steve, I'm really honored to have you in this podcast.
Oh, thanks, Morano. It's good to talk to you again.
Okay, thank you very much. The discussion about this podcast is to discuss about cloud design patterns and architecture in general, but mostly focusing on the microservices architecture. And the most interesting thing would be to actually hear your personal experiences with it and to tell us firsthand what you think works and what does not. So having that in mind, can we maybe start off with briefly discussing the monolith versus microservices approach today?
Just as a real quick background and architecture, monolithic architecture is basically where the whole app is running in one process and usually lives on one server. Maybe there's a database involved separately, but you distribute it essentially as a unit. And then with the microservices architecture that's growing in popularity, you generally have a lot of much smaller applications that need to coordinate and communicate with one another somehow. And the big push to go to microservices is being driven by one, the cloud, which makes it much easier to build and distribute these types of apps. But also, if your application's needs grow beyond a certain point, it becomes difficult to continue to vertically scale and oftentimes even horizontally scale your full monolithic app. And so microservices provide a way to grow beyond a certain point.
The way actually I feel about this is that, I mean, I've seen it progressing through decades. We are moving slowly, and I would say in the right direction. But in my mind, microservices approach is kind of an evolution, definitely not a revolution, but evolution of the SOA approach that we had, and that was really very popular and really made us much more efficient than before. Would you agree to that statement?
Yeah, I think it's definitely evolved from service-oriented architecture or SOA, and it's just a matter of taking SOA to sort of the extreme programming approach of taking it to the extreme and making it so you have microservices instead of larger grained services that are bigger. The focus on doing small units of work in each microservice and having the responsibility to be very finely tuned, I think is the biggest thing that separates a microservice from a standard, SOA-like service.
I agree, and I think it would be beneficial to maybe mention, and only if you agree, I think that the monolith approach, it's still not, I mean, there are circumstances, there are specific use cases when monolith would work well. I mean, it's not like we have to abandon that for good, and it's only microservices, and I'm not being exclusive over there. Do you have the same opinion, or maybe you see it differently?
No, absolutely. I think most applications being built today should probably be built as monoliths, especially if they're greenfield, new projects. Because if you build the monolith in the right way, if you build it using a clean architecture approach where the dependencies are well defined and well understood, it's not that difficult to take a modular monolith with loose coupling and dependencies that are well understood and start to split that up into microservices if and when it becomes necessary. But starting with microservices in many cases is a form of premature optimization.
That's an interesting statement, because I see people start with microservices approach right away over there. Okay, this goes also in line with, people would say, oh yeah, you have to have a domain model, you have to do like domain-driven design, and then one of the most popular, this is like a DDD pattern, and then one of the most used approaches is like doing domain model. But sometimes you just don't need it. If something is rather small and simple, then doing that would be like an overkill. So it's all about the trade-offs. I would say the architect, they need to understand when they need to move away from monolith to microservices. Also, if a specific microservice is implemented, then would they really start with do the domain model, even if there isn't so many concerns that microservice tackles, right? It's all about trade-offs, and architects should be really smart and really thought it beforehand before going into the implementation, I would say.
Yeah, certainly. It is for sure all about trade-offs in architecture. And there's a whole classification of apps that need to be built that help businesses run that are essentially CRUD, create, read, update, delete of some back-end data. And domain-driven design and certainly microservices are totally overkill for that scenario. I mean, you're basically talking about many business processes are run in Excel or something close to Excel, and they just need to get Excel into something that's hosted, and maybe they can use it from multiple devices. And to be able to take sheets in Excel, turn them into tables in a database, and give them a grid or some other simple UI to be able to edit that doesn't require microservices, doesn't even require DDD, and you could probably script that and generate it with some tools for rapid application development that would generate the UI for you, and be done in a matter of weeks instead of months or years, like some of these larger projects.
Yeah, I guess it is all about the trade-offs. So I agree. When we come to that, so for the microservices today, it is. I mean, since we are using it for several years already, but now I think at least the way I see it, every year this implementation is like kind of booming. Everybody's moving over there, and we have like more and more projects just moving, legacy projects, trying to re-architect the existing systems and move them toward microservices. Or the new ones that are starting, there are very few chances that people will go with anything else but employing this architecture. Do you think that it's a generally good approach, or there is no rule? It just depends on the situation.
I definitely wouldn't say always do anything, and I think you would agree with that. The standard "it depends" is still going to be there, but I do think that it's easier now to create and deploy and manage microservices than it ever was in the past. I mean, the other factor in the industry, I think that's moving us in that direction is we aren't dealing with physical machines very often. In fact, we aren't even dealing with virtual machines anymore for the most part. We're dealing with containers that just wrap, like Docker containers that just wrap a single process. And then on the hosting side, we don't have to manage physically the data center and all those devices ourselves even. We have things like serverless now, where you can just take a function, a unit of code, and throw it out there and host it on Azure or AWS, and that's the unit of deployment now is down to a function, a service. It's much, much easier than it ever has been as far as the cost to build and develop and deploy these types of micro units of functionality. I don't think your whole system has to be necessarily a microservices architecture for you to get the benefit of being able to take some parts of it and deploy those as independent services. I see that quite a bit.
So kind of a hybrid approach in there.
That's right.
As you Americans say, there is no such thing as free lunch. So I guess there are advantages to using microservices, but there are also disadvantages. The one that I see often is like it is really challenging to provide communication between microservices, and also when you have really complicated workflow, like a business workflow that you need to implement that touches upon dozens of microservices, it is really challenging on how you actually orchestrate that. So because there are different concerns over there. First of all, each microservice is ideally, it is aligned with the bounded context, which is a term from domain-driven design, right? And ideally, it would be like that. So we want microservices to be autonomous. We do not want microservices to be tightly coupled with anything. Otherwise, the whole point of the architecture is lost, because we cannot bring them down and deploy new versions and everything. So also in the background, there is like some kind of message broker, because we still need to communicate in between them. And this is like one of the tenets in the distributed architecture, is to use some kind of message broker. So there are a lot of challenges over there. And probably the biggest one is, how do you really separate the execution steps over there. Let's say you have 20 microservices or 50 microservices, or I don't know, is that realistic? But okay, 20 microservices is definitely realistic. So if there's a like medium level complicated business workflow, and you need to have like, I don't know, let's say 20 steps, that will go, and each microservices is going to have to do their part. But there is also a temporal concern, something you cannot do something before you have gotten results from some other microservices. So often it gets really complicated. So generally there are two approaches: orchestration versus choreography, and they are really kind of different. So what do you think about this? Because this is kind of, for me, this is okay, you use microservices, there are many benefits, but first this is like a landmine, you hit it very soon, and then how to deal with it. What do you think from your experience is the best approach?
I think you can easily start out with choreography when you just have a couple of services, a small number. And so let's say you start out with a monolith and you've carved off a microservice to do some specialized function. And so the monolith, maybe it raises an event or it puts a message on a message bus, and the service picks it up and it does whatever it's supposed to do. And then maybe it drops a message back that the original app, the monolith, picks up and sees, okay, it completed successfully, or it didn't. And that's how things work with just choreography, where just the messages are the workflow, and the services know what to do because they see those messages. When you start adding 2 or 3 or 4 or more of those things, and they start talking to each other, not just to the monolith directly, now it starts to get more complicated, and the actual workflow of the steps that need to happen in the order in which they're supposed to occur is not explicit anywhere typically in that architecture. It's in the messages. If you want to change the workflow, you need to change what messages you're sending by whom, and then what they're doing when they get them, right? But you don't have like one method or one place, one config file that you can go to that says, here is the logic, here is the workflow, here's what depends on what. If you are moving from a monolith to microservices, usually the monolith will act as the orchestrator. It will call the first service, make sure it's good or not, then call the second one, etc. If you start moving away from that and you just have a full microservices architecture, then it is helpful to have an orchestrator, if only to be able to better visualize and understand what's going on, I think.
I have exactly the same feeling about this, but it's kind of, the jury is still out there. I mean, there is no definitive decision on this, but people tend to lean toward either of these, and they are really stick to it. So I also think that it depends, or as everything, as you said, it depends. But still, here's my personal experience with it. Using the choreography. It makes things more simple. You do not have the orchestrator. There's nobody up there like controlling everything. So this is like much more in line with the kind of the idea of having microservices that are totally unaware of each other, and somebody else is kind of choreographing the steps that need to be executed in order to achieve the goal of whatever the business flow is. But then again, and also there is this like notion of orchestrator being coming from the SOA, which is true, like it's older than this new approach, so it is true. Still on the orchestration part, and I don't know if you agree with this, but on the orchestration part, there is important thing, like you can execute sagas over there, so you have full control over there. And then since each step over there has compensations, then you can employ the compensatory mechanism in order to revert back any number of steps if something fails. Like you have 10 microservices, and then 7th microservice fails, you can roll back and recreate the state as it was before it started executing. So this is not easy to achieve if you have choreography. And the second biggest challenge for me, and where I would still go with the orchestration versus choreography, is like when you employ choreography, then you are basically building a part of the flow into the microservices. So yeah, they are going to execute that way, but you somehow have to have the overall control over those. and slowly you will have to kind of add functionality in each of those microservices so that they can execute in like a part of the workflow of the business workflow, which is something above over there, abstract for the microservices. They don't have the insight in all of that. They are just doing a part of the work, and then slowly you are, as you are moving, you are progressing. The software is kind of getting older, 1, 2, 3, 5 years. There will be a bunch of those. And then when new people come to work, it would be really for them, in order to understand what's going on and to acquire the knowledge of how the system works, they would have to be hopping in between microservices in order to catch what goes where and what is executed in which microservice in order to get a full picture. While in the orchestrator, even though it is a little bit like a clunky implementation, choreography is much more kind of lean and kind of elegant. I agree, but still, if you look at the orchestrator, there is a number of steps over there, and you can easily figure out what's going on, and then you can dive in down there and kind of go into the details. So this is kind of my view of all this. So which is pretty similar, I would say, with your experiences.
That's right. I don't think we disagree. I mean, the thing about it is somewhere in your application, if you have rules for things like what to do when failures happen, and they will, those rules have to live somewhere. If you are doing choreography, every service needs to have some information in it baked into its logic of what to do when something fails. If it needs to do a compensating transaction in another microservice, right, then it needs to know how to kick that off. It needs to fire off another message or make some synchronous call to that other microservice or whatever it is. And instead of that recovery logic being in one place in the orchestrator, now it's spread out into every different microservice. And if you add another process that, another workflow that has some more logic like that, you now have to touch every microservice that's involved potentially in order for it to be able to properly handle with those error states. Whereas if you had the orchestrator, you could have each one of those microservices do what it does, and if there's a problem, just let you know, right? It gives you some type of response that tells you there was a problem, and then it's the orchestrator's single responsibility to do whatever it needs to do in response to that error.
You have mentioned the clean architecture approach. Could you tell us a little bit more about this? Because I really want people listening to this podcast to understand it, because I think it's a great help for anybody starting in that direction.
Sure. So clean architecture is something that's been around for a while. I didn't invent the term. It goes by a bunch of different names: onion architecture, ports and adapters, hexagonal architecture. Are all different names it's had over the last couple of decades. And it's just a way to structure an application, not a distributed application, but a monolithic application, so that it has some composition to it where the domain logic, the business logic, lives in the core of the application and doesn't depend on any of the implementation details, like a database or API calls or the file system, right? It's just logic, it's just code. And then it exposes abstractions or interfaces, or ports and adapters calls them ports, for the different types of dependencies that it needs. So if it needs to talk to a database to do persistence, it's going to expose an interface that is for persistence. And then you can create an implementation of that, an adapter that knows how to talk to a particular persistence provider, whether that's SQL Server or MongoDB or a file system, it doesn't matter. But you plug it in, right? It's a plug-in architecture. And what this does is it follows the dependency inversion principle from solid principles. It makes it so that your implementation details, the low-level logic, depends on the high-level abstractions in your business model. And I see clean architecture as a great way to build loosely coupled systems that are very easy to test, very easy to change. And microservices in particular are great to set up like this if they have any complexity to them at all. I mean, if they're super trivial, then yeah, just make it an Azure function or something and deploy it serverless. But if it's got some actual complexity involved in it, which most of them do, then a very small clean architecture style solution, Visual Studio solution, if you're building things with Microsoft, can be the way to go. And I have an open source solution template that you can grab from GitHub that basically lets you get started, and it has all the patterns and things you need, and all the projects in it are depending on one another in the proper direction. And so it's very hard for you to do the wrong thing, because the core project is not something that depends on anything else. And your infrastructure project, which is where you put your adapters that talk to external dependencies, it depends on the core project. And so you're not going to get that dependency wrong, because Visual Studio won't let you create circular dependencies or have dependencies in the wrong direction.
Thank you. I've used it, and I think it's great. I think definitely everybody should check it out, and it's available on GitHub, right?
That's right. /Ardalis/clean architecture.
There's also one, I think, one more important thing, which is kind of a general nature, but it's really, in my opinion, people have different approaches over there. I mean, when you ask them, they even come up with a very strange solution. So it's like kind of a cornucopia of awkwardness, I would say. There you can hear everything over there. What is your opinion about how to actually start? If there are architects who really want to start with this, where would they start from? So the questions they usually ask is like two. Should they go serverless or containers? Containers seems to be, at least in my experience, people kind of find them intimidating to certain extent. And this is serverless. Obviously, it is much easier. But then, what do you gain? What do you lose? This is like one question. And the second question: are there any good like platforms or frameworks over there? I know there is like Dapr, DAPR, which uses that sidecar implementation supported by Microsoft. They have released first version, so they are kind of production ready, and they can help with building the microservice architecture. There's also TYE, right, framework. Well, actually, they say it's a tool. That's how they think of it. It is available over there, but then it's geared toward Kubernetes and reusing the existing networking infrastructure of Kubernetes in order to kind of provide a playground for building microservices architectural solutions. So what do you think? First question is serverless versus containers, and the second one is would you start like hitting your solutions off how you want to do it if you were an architect, or would you use any of the existing frameworks or tools for that purpose?
For me personally, I usually start with containers, and that's because I can run them locally very easily versus serverless. They don't have any vendor lock-in. So if it hasn't already been decided which cloud vendor or whatever might host the solution, I don't have to make that decision up front. I can make that decision later, and I can change my mind if it turns out that one of them is going to be a lot more expensive. Whereas if I'm choosing serverless, I'm usually locked into Amazon Lambda, Azure Functions, whatever that might be. And it's gotten a little bit better where at least they both support the same set of languages, but the calls that you have to use, the frameworks that are available, are still going to be different between them to some extent. So it won't be as easy to shift as Docker containers. So my usual starting point is containers for that reason. I've also run into issues when you try and use serverless, and there's that startup time from a cold start. And so if you're using it in the actual process of a user request, where you want that user request to complete in a couple hundred milliseconds, if you happen to need to scale up and spin up a new serverless instance in order to support that, that oftentimes can take multiple seconds, and so you either have to keep those all running so that never happens, which is then eliminating one of the benefits, which is that you only pay for what you use. Or you just got to be okay with the fact that sometimes you're going to hit that cold start and have that performance hit. And so at that point, I mostly prefer to use them for things that are not inside of the UI experience of a user, but something that's a background task that gets kicked off. So that's the serverless versus containers, at least from my perspective. What do you think, Murano?
No, I agree. Yes. So that one is like, I mean, if you were to use functions that way, then you might as well go with the ops services. Like the one of the benefit is that you really pay for just for the time that they are running,
Right.
But yes, if it's in a context of a request that needs to return, then no. But you're totally right. If you are doing something in order to achieve the eventual consistency in the microservices, which is usually how it should work, then yes, functions can be a good choice. But people just use it because of the simplicity, I would say. But yes, that is one of the big downsides of going serverless. Containers. I think they look, as I said, intimidating to people, and you kind of really need to learn a lot. The learning curve is really steep if you are just starting with containers and everything. But then later on, you learn to appreciate the benefits of it. I would say. So I would agree with you. So what about the frameworks? Do you think there is something over there that is worth looking, or it just depends on people's preferences?
I haven't personally investigated Project Tie that much. I've seen some presentations on it and it looks interesting, but I haven't used it on a real project yet. Dapper is getting some traction and does have some folks that are definitely using it, and it provides some good services if you're using Kubernetes. So I do see Dapper being used. For a lot of folks, they're still just building everything by hand. With .NET Core, that's easier than it's been because it's with full framework.NET, it was Windows only, and you had to host things on iOS, etc. All that stuff is in the past now, and pretty much everybody's on .NET 5, moving to .NET 6, and reaping the benefits of being able to run on Linux and run in a much smaller system. So a lot of the companies that I'm working with have a bunch of legacy code. A lot of it's written in .NET and is not built to run in containers or to run in the cloud. And so that's what I help them with. And actually, I wrote a book for Microsoft on how to do this, how to modernize your code and move it to the cloud. That's a free ebook. But that's what we help with is how to get from that more legacy approach to something that can use microservices and containers and the cloud without having to just push all your legacy stuff up as virtual machines, which gets very expensive.
Great. Yeah. Thank you for this insight. So this was a really interesting discussion. I think these topics are really all like hot topics these days. And I'm glad we had a chance to have this short talk to discuss them. Thank you very much for being part of this podcast.
Thanks a lot, Morano. I'm happy to be on anytime.
Thank you very much.
Thank you for listening to Authority Partners podcast. Stay tuned for the next episode.